Okay, so we're using Pufferfish mainly today as the plugin that we're going to go over. We're going to use a thing called twisted boxes, and I'll explain what that means in a computational design sense. And we'll be making this necklace form out of it as an example of basically how it works. And then if we get through that today, we'll also be using twisted boxes on top of our shortest walk workflow from last week to make more of a organic, complex wearable form with twisted boxes. So taking it from something simple like the necklace, and then if we have time, we'll move on to something slightly more complex. It's really not that much different. It's just using a different input. So I'm going to open up a new file, and we're just starting with whichever base human form that you want to open. So I'll go ahead and use this one for today. Actually, let me use one that's actually in the center so it tracks with what you guys are doing as well. Okay, this guy's massive. Whatever, you can use either one you want, but if you have the one from last week, we're good to go. If you have the AR one, I'm going to make this one a little bit smaller and then we'll move on, and I'll show you how to do that as well. It's a good thing to look at. But let's pull both into the same file. Okay, so we're starting with the base human form again. We're going to model around this. But to start, if you have the AR form to make this one smaller, is we can scale it down inside of Grasshopper. So there's a couple inputs here, the geometry to scale, the center of scaling. So it's going to scale around this origin point, and then the factor to scale at. So if we use a slider, we can go from 1 is going to be 100%, so normal size, and then anything smaller is going to make the entire model a multiplication factor that much smaller.
What was the maximum I put?
I just put 0.01 to 1, okay. Just because I know I want to go smaller. If you have any scaling factor over 1, it's going to get bigger. Anything under is going to get smaller. Okay, so now that my AR form is down to size, everyone should be working in the same sort of size range. So hopefully most of my numbers track with what you will be using as well.
You do preview off for the big one?
Yeah. I only have the scale previewed on at the moment. Anything else would clutter up the scene a little bit too much. So some basics for this necklace that we're going to make. First thing, twisted boxes. Second thing is going to be the texture that we use to create the volume of the necklace. And that's coming from the Mesh Plus plugin. We don't need Mesh Plus for this example, but the nice thing about it is it has this section of pre-built volumetric shapes that we can use to just pattern out the necklace. So I'll give you a little bit of an overview. A twisted box, as the name implies, is a box mainly. That's pretty much all it is. We can have one box, we can have hundreds of boxes, we can have thousands. But the nice thing about the twisted box is we can put any kind of geometry inside of it. So I could put this little diamond pyramid thing. Cool. And that is now bound to this singular twisted box. But what the box does is it allows us to very simply move some of the vertices around to stretch out how this box looks. So if we were to do that, the box would be a lot more stretched out. The drawing is not to scale. So as we stretch the box, anything inside of the box is going to be pulled as well. But the nice thing about having the box is a very, very simple form. And we could put anything more complex inside. So this little diamond shape has a few more polygonal faces than the box does, but we can still morph it by just pulling the 8 corners of the box. So it basically just allows us a really simple way to morph geometry from one shape to another shape. In the sense of the necklace, I'm using one pattern, so one kind of diamond, and then with, say, 20 boxes, creating a linear pattern out of that. So we're going to build that up, and we're going to use one of the volumetric pieces that comes with Mesh Plus to do the task of creating this internal geometry for us. But we could, if you wanted to, design your own geometry that'll be multiplied in an array in these twisted boxes if you wanted to. But today we're going to keep it simple with Mesh Plus. For Mac, did Mesh Plus, you have that? Okay.
Oh, yes, I have it.
Perfect, yeah. Just making sure. So everyone should have this. So we have this menu up here in Mesh Plus with all of these different textures in here. You can pick any one you want, and it'll give you a different texture. I'm going to be using Batwing today. To me, I like this one the most, but you could use any of them you want, and we can even at the end play with changing them in and out and seeing the different kind of patterns you get. Yeah, it's under volume. Yep.
Sorry, when I'm searching it up, it's not coming up.
Are you typing in Batwing or are you going to the Mesh Plus tab up top?
I don't have the map, the M plus tab.
Okay. Yeah, so the M, if you don't have it, if you can see Discord, was just in this original GH plugin zip file. So there was Pufferfish and Mesh Plus in there. So if you don't have Mesh Plus, you can get it here again. You can download that. Or the other case might be you already did that. It's just not unblocked in your settings in the file where we usually install plugins. So check both of those places. If that doesn't work, I posted a video last week in Discord that tells you how to install plugins. So reference that if there's any issues. But I'm going to keep moving forward with this tutorial.
Okay.
So I have the Batwing up. You can have any of them up. There are some other ones that might have slightly different inputs. Like this one has more inputs, but the only thing that really matters is this G0 for us today. You can play around with the rest of them later, but we just want to basically create just this shape. So the simplest thing to do if you have G0 is put a number in there. So basically in Rhino, it's not showing up with anything yet because we have this three-dimensional volume, but we need to define a place for it to sit. So we need to define a rectangle in Grasshopper that it'll exist within, and then it'll show up in Rhino itself. So to create a rectangle in the scene, easiest way is to use the rectangle component, the orange one. The black one is just an input, so stay away from that, but we'll be creating a rectangle with Grasshopper, so we'll use the orange one. With this, we just need an X and a Y size to define the rectangle. So with X and Y, we can put in numbers or we can put in domain values. It'll just change a little bit of how the rectangle is created. So if you remember from the Voronoi workflow, we did use the same component. We used a rectangle and we put just number values in X and Y, and then we had the rectangle growing, if you can see Rhino, like out in the X and Y direction. But if we add a domain, we can have it centered around the origin. So I'll just do that way today to show a different one. So in order to do that, basically we want X to, instead of being 0 to 1, we can do -0.5 to 0.5. Will center the box for us. So to do that, the easiest way is to construct a domain. So we can type in construct domain. If anyone doesn't know what a domain is, it's kind of like when we type in to get a slider, we do the lowest number, ... the highest number. It's basically a domain too, from lowest to upper bounds. So construct domain will do that very similar thing. So we have A and B, which is going to be the start, and then B is the end of this domain. And then coming out, you can see by default it's 0 to 1, but we can make these numbers whatever we want. In this case, I'm going to do -1 to +1. So it doesn't really matter what the rectangle size is as long as we have a rectangle. One is just easiest. So we can use a panel or you could use a slider, but we're not going to change this number at all. So it doesn't matter either, but for workflow sense, I always use a panel when I know I'm not going to change this number in the future. So it's always going to be 1, so I'll just use a panel. So in order to go from -1 to +1, we could add a second panel that has a -1 number in it, or we could just use this panel and create both the negative and the positive from it. In order to that, clearly we already have the positive number, but if we type in negative, we can get a really simple component that'll just take any number and output the negative value of it. So I'll use that. And with this, we want the domain to be from -1 to +1. So if we plug the 1 in, we'll get -1 coming out. So we can add that to A, and then we can add the +1 to B. So now if we hover over the output of the domain, we should see -1, 2, 1. I'll pause for a second just because the wires have started to overlap. So with this, we should now have a domain -1 to 1, and we can use this for both the X and the Y domains dimensions for the rectangle. Once we plug them in, we should see we get a rectangle within the XY plane. It might be a little bit hard to see just because it's overlapping with the grid of the plane as well, but just know it's there. Cool. Once we have this rectangle, we can use this to define the base boundary for the batwing. So if we plug that into G0, we'll get a shape that comes into Rhino. And in Rhino, I'm just going to bake out, you don't have to do this, but I'm going to bake out the batwing so we can see what it looks like as a piece of mesh. So this is what it is. It doesn't make too much sense in this low poly version. But if we can imagine all of these textures, that volumes that Mesh Plus gives us are tileable. So the left side of this volume is going to match up with the right side of this volume, and that's going to be the true for any side of this shape. So it's infinitely tileable to connect back to itself again. So that's the nice thing about using any of these volumes from Mesh Plus, is they're all like that. So we'll get a pretty nice pattern no matter which one we use. If you make your own shape, which we could make any shape and use that, it might not be infinitely tileable. So there's that. This is just a nice, easy input for us. So I'm going to delete that. So we'll come back here. See anything? Okay. So there's two outputs from the batwing. The output that says out is just some information about what's going on, but A is going to actually be the mesh, which is what we're going to use as a pattern to tessellate around this form. So in order to do that, we'll have to create a twisted box. In Pufferfish, if you look at that plugin, there is a section for twisted box, and there's a lot of different ways to create twisted boxes. You could create them off of a mesh as a certain distance. You could use a curve to create it. You could use surfaces, lofts, arrays, a lot of different things to create a set of twisted boxes. The one we're going to use today is going to be the twisted box sweep. So this one right here. What we're going to do basically is define 4 curves And then if you're familiar with what sweeping is, we'll create a surface going between all of those curves to make a surface. Except in this case, the surface that we are given is going to be a twisted box. So we can put volumes into that, all of those boxes. We'll define how many we want. So I'll pull that out. We can see with the twisted box sweep, it's got a good number of inputs here. All of the R inputs are going to be the rail curves. So that's going to be the curve that we actually define in Rhino. So we'll take some time today to actually do some modeling in Rhino. And we'll just be modeling curves in Rhino. So first thing to modeling like on the mesh in Rhino is the meshes of the people right now are just within Grasshopper. So if we were to try to use a curve tool to start drawing on the shape, if it's not in Rhino, it's going to be really hard to draw on the mesh. So what I had just done was you can come over to either the mesh from last week or the one from today. And if you right click in the middle of the component, there should be a bake option. And if we hit bake, it'll take it from Grasshopper and put it as a physical object in Rhino. So we can actually use the vertices of the shape in Rhino.
So cute. Pull it away.
Yeah.
It's like those 80s montages.
Right.
When I try to
Yeah.
bake mine, it's telling me that it can't do it because well, it can only do it when no other commands are running, but I don't think I have anything else running.
Yeah, so if you just click on the Rhino window and just hit escape, it'll cancel anything that's in the command line. And then you should be good to go bake from Grasshopper again. I have that issue often.
Oh, okay. Perfect.
Yeah.
Thank you.
Is this
Okay, so was everyone able to bake? Any issues there getting it into Rhino? Okay, I got thumbs up. Nice. Okay, so once it's in Rhino, the nice thing about this is we can actually use the vertices of the mesh to create curves around. The only thing is it might not work for you, and that's just because we need to make sure we're turning on this O snap button on the bottom. I think Mac, it's like on the top or on the side or somewhere else. But there's this option for snapping. So when we're modeling in Rhino, we're snapping to the vertices, and we can turn on all those settings down here. So we can snap to the end, near a curve, on points, on the midpoint. All those things are good to have on so we can actually get the curves to work correctly as we're creating them.
I have a.
Yeah, I'm not sure what Smart Track is, but Gumball, always good to have on. OSnap, also usually always good to have on. Okay, so here we're gonna make a necklace. Actually, you can make whatever you want. I don't really care. I'm gonna make a necklace just because that'll be easiest to show. Thank you, Grayson. Smart Track is useful. Interesting. Okay, cool, cool. If you can tell, I don't model in Rhino often. I'm usually always in Grasshopper, so good tip there. So I'm making a necklace. I'm going to draw a curve around the neck, and then we're going to copy it 3 times and make it into like a shape where we can loft between all 4 of them. So I'll explain what we're doing. So with the curve, I like to use the second curve in the curve menu. The only reason is the second curve actually follows the vertices you set. The first option by default kind of smooths between all the points. It's a little bit harder to control, so I like using the second one. But up to you, as long as we get a curve. So I'm using that second tool with the end near selections turned on. We should be able to snap the point to one of the vertices on the mesh of the model that we have here. So with this, I'm going to start in the back of the mesh, just so we don't see the seam at the end as much. But up to you if you want to start wherever you want to start. And I'm going to go around. I don't know where it went. Hold up.
I'm not.
Yeah. Like the snapping with the tool? Do you have O snap turned on?
Yeah.
And then do you have also all these checkboxes turned on at the bottom? So you need to have like end, near, point, mid. Those are all good to have on generally.
I only have the end.
Okay. Yeah. Point's gonna be the one where you have that checked, it'll snap to vertices in the scene. So you got it? Cool. So yeah, got a chat. Let me see. If you convert the mesh to NURBS, Grayson, that's fine. The mesh in Rhino, we're not going to end up using. I'm just using it to model around. So, oh yeah, I do see the vertex selection. That's also good to have on the right there. But yeah, whichever way you're able to be able to snap to the mesh, that's fine. We're not going to end up using the mesh in any capacity at the end of the workflow, just for modeling a curve on it. So with the mesh, I'm able to select points and start adding a curve around. I do realize it's hard to model around the neck because you can't orbit. For context, last year I had 2 mice with me, one of them that did orbiting and the other one that did selecting. So I didn't have this issue last time, but everyone else probably did. So are you able to orbit? Maybe I'm just doing it wrong. But doesn't that cancel? Oh, never mind. Okay, we're back. So yeah, I'm starting in the back, kind of like on the spine line, and I'm creating a curve just wrapping all the way around. Doesn't matter how exact we are here. We're going to come back in a minute and actually clean this up. So one thing to note, I don't want to actually end the curve. You could, you just have to do it for all 4 lines. So in my case, I'm not going to end it, because if I go back to the original point, it'll close off the curve. I'm going to leave mine open. But you should be able to do either, up to you. But I'm going to leave mine open, so. Okay, so once we have the curve in the scene, you can hit enter to finalize it. So it's now in the scene. I'm not making a curve anymore. If we click on it, we should get the control points popping up. So these little dots and dotted lines surrounding the curve. If you don't see them, you can also turn on control points with this control point option on the toolbar, but they should come on automatically. Let me know if they don't, but they should. You have an issue over there?
Yeah, for some reason, it's like, I don't know what.
Like the 4 different screens, or?
No, this. I was like trying to draw the curve and then it.
Oh, it just deleted itself.
Yeah.
Oh. Is the mesh just gone? Looks like it.
It looks
Whoa,
like it's just
my
different.
necklace is going through her body.
Yeah,
Oh no.
Okay, so maybe to help some people out, one thing we can do with the base mesh, since if you're selecting the curve and the control points, you might misclick and select the mesh itself, which we don't want because we don't want the mesh to move. Is if you have your layers pulled up in Rhino, we can create a new layer just for the base mesh of the person and turn off the selectability of it. We can kind of lock it so we can't select the person anymore, and we can just select the curves. This will just make things easier so you don't select things you don't want to select. But with the layer panel pulled up, by default, it probably already has these 5 layers here. If it doesn't, we can click the button up top to add a new layer. But either way, as long as you have a layer, we can select the base mesh of the person. If you know how this works, cool. And we can just change it to that object layer. So we can put the mesh of the person onto this layer. And then once it's on the layer, I actually don't like these colors, so I'm deleting everything.
How do you do that? How do you select object?
Yeah, give me 1 second. I want this to be black. Okay, cool. So yeah, we'll select the object that's in Rhino. And then with that layer on the right-hand side, if you right-click on the layer, we can say change the object to be in this layer. And then it'll go in. And the nice thing about this, once it's in that layer, is we have these little options over here. First one is going to be the view. So we could just hide and unhide the layer, but we don't want to do that. What we want to do is turn off the lock. So we'll actually just lock it. If we lock it, we can come back and we can see if I click on the mesh, I can't actually select it. So now it's just like in the scene, and it's a lot easier to work with the curve now because I can only select the control points and the mesh is not going to be able to be selected.
I have tried
Yeah, we could put the curve on a different layer if you really wanted to, but only thing is important is the person is on a layer and we lock that layer. Okay, so at this point, back to the curve that I was modeling in Rhino. If the curve, it's probably going to be going through your mesh, just because we modeled it straight on top. So we can come back and grab the control points, and with the arrows or the little translation tool between the arrows, we can go ahead and grab all the points and move them just slightly away from the mesh. And this is up to you how you actually want this curve to look. It could be as crazy or as simple as you desire.
You didn't close it?
I didn't close the curve. It shouldn't matter as long as we do all four the same. So we're going to be making 4 curves. As long as they're all the same, either closed or not, it should be fine. Another little tip here is with the gumball, so the tool that we use to move the points around, by default, it's always going to be locked to the XYZ axes, which is fine. But sometimes the more organic we get in modeling, it's good to change the gumball from standard to, what is it called? To align to the object itself. So if you see the gumball button at the bottom down here, we have it on, clearly. But if you right click instead, we have this menu that pops up when we right click on gumball. And by default, it's going to be aligned to the axes of the world or the plane by default. But if we change it to align to object, now when we actually use the gumball, we can see that now my Z axis is actually pointing towards the curve. And that's going to be true no matter which way we grab a point. It's always going to be aligned to the point itself, which is just nice because usually when we're modeling organic, we don't always want to move things on the XYZ axis. It's a little bit locked in space. So this is just a little more fluid. Yeah. Yeah. So do you have your gumball button? I think it's the top for Mac.
Yeah.
Yeah. So if you right click on gumball, your panel looks a lot smaller than mine. So right click. Holding shift. Interesting. Sure on Mac how to do it then? There's probably another menu, but it's not going to be necessary for this to get that on the aligned to object. It's just a nice thing to know about when we're moving things around to not always align to the axes of the world. Okay, so with this one curve, I've moved all the points a little bit away from the mesh, so it's kind of hovering on top now. For a loft, or for the sweep that we're going to do, I'll explain with this little drawing what we're doing. So we have this one line currently, but we need to make 3 more to actually sweep it around according to what the input wants for this box sweep. So we have this one here. What we're going to do basically is copy it, move it over, and then do that 2 more times. So we get 4 curves. Once we have these 4 curves, we can actually do the sweep, and it's going to be important how we input these curves into this component because we have 1, 2, 3, 4. We want to make sure that we do it in either a clockwise or counterclockwise order. just so this kind of looks like a 2, just so we go when we input the curves from 1 to 2 to 3 to 4, and then we'll get a full sweep around all 4. And this will make a surface that goes over top our curves. So basically that's what we're going to do. I'll do it in Rhino now, though, to show. Okay, so back to the curve in Rhino. We have this original one. We can duplicate this to make the second one. So a couple options there. We could Control-C, Control-V to copy paste it in place, one option. Second option, with the gumball, we could, while holding the Alt key on the keyboard, we can pull the curve away and this will automatically duplicate it while we're moving it. So copy paste, or if you hold Alt and move it, it'll also duplicate it. So 2 options there. Okay, so with it copied away, we can go ahead, and the first simplest option is just going to be to create this inner surface that is going to interface kind of with the neck on this model. So we have the one going around kind of the collarbones right now. But you know, this neck is going to be pretty volumetric as a piece, if you remember from the beginning of class what I showed you. So I'm going to pull this curve away, like up a little bit on the z-axis. And then I'm just going to want to fit it to the neck. And this is up to you. It could be whatever shape you want, but I'm going to manipulate this curve now. 2 ways to do it. The first way is we could do what we just did and grab all the control points, and we could move them in to be closer to the base mesh, or with the entire curve just selected. We could, with the scaling tool on the gumball, just scale the whole thing down a little bit. That's going to probably be the easiest. So we can scale it down uniformly, and then we could scale it, move it around, just so it gets to what you think is the best. Up to you on the creation of curves. So now I have 2 curves in the scene. I'll just rest a minute so everyone can make the second curve. Yeah, so if you have one of the curves selected, we have the scale tools over here. So we have the red box. If we order around, you notice we also have a green box, and then we have a blue one as well for the 3 axes. If you grab one of them, I'm going to grab the X scale, and we can do scaling on the X axis, but if I hold shift at the same time, it'll do it uniformly.
Mine is like attached to the vegetable.
Oh, okay, yeah. So if you have this first curve, and instead of moving it with the blue arrow, if you moved it with this blue circle, it would do that. It would make like a surface there. Yeah, so there's a lot going on in the gumball. So make sure you're grabbing exactly what you want to grab within that tool. There's a lot of buttons there. Okay, so with these curves on the neck, we've got the neck there, and we've got 1 curve, we got 2 curves. But to finish off this necklace, we'll make it very big, as I said. So we got 2, we can add, say, a 3rd one that goes up here, maybe a 4th one down here. And then we'll get this very, very big shape. So that's what we're going to aim for. So I'll make 2 more curves. So same thing, we can duplicate these curves again, scale them up, probably the easiest thing. So I got my 3rd one there. Yeah, so if you grab the scaling tool, which is the square, and then you hold shift at the same time, it'll do it uniformly. But you can also come in and say just grab just the y-axis and scale it down in that dimension, just to do some non-uniform scaling. Yeah.
To duplicate, you hold shift.
Yeah, so I have this one selected. If you hold Alt and then grab the arrow, it'll duplicate while transforming it. So I'm just going to make my fourth curve. So we got 4 curves. So you could use scaling to change the size of it. But now that I have all 4, we can actually go figure out what the silhouette of it is going to look like. And we can do that granularly by actually affecting the control points. So we can grab the control points and make this silhouette pretty much whatever we want it to look like.
What did you do with the fourth? Apple?
Yeah, just the fourth curve. So
Yeah.
all we need is 4. It doesn't have to look like this. But yeah, so I made the first one. We duplicated that, made it a little bit smaller for the second. And then I duplicated the first one again and just made it bigger for the third. And then for the fourth, I just took that third one and just moved it up a little bit. And I got all 4. And then I went in with the control points and kind of pulled the silhouette, around to be a little bit different.
Could I expand both of them together?
Yeah, so
Select both of them.
like with scaling, so you can select 1 and 2, and then you'll get a singular gumball tool for both. And then I could pull them both out on the x-axis and make them a lot wider if I wanted to. Yeah. Okay, how's everyone's curves coming? Ooh. Good to move on back to Grasshopper. If anyone on Zoom needs help, let me know. Okay, so back in Grasshopper, we're going to put all 4 of these curves into Grasshopper so we can use them as rail curves for the twisted box sweep. So first way to do that, and we've done this a bunch of times before, maybe not with curves yet, but in order to grab the curves from Rhino and put them into Grasshopper, we can use the component called curve. This time we want to use the black hexagon icon. All of these are reserved for taking geometry from Rhino and instancing it in Grasshopper. So anytime we want to pull something between the two spaces, we can use any of these primitive components. So we got 4 curves. We'll need 4 of these curve inputs. So I'm going to duplicate this 3 more times, get 4 of them. Yep. Yep, just curve. Yeah, it should have no inputs because it's not something we can define in Grasshopper. It's just for taking geometry from Rhino to Grasshopper. So with these in the scene, again, as I mentioned earlier, it's important how we put them into Grasshopper. We'll have to do them in a clockwise order for the sweep to work correctly. It'll still work if you get one of them mixed up, but it will look very different from what we're aiming for. So with the twisted box sweep, as we've seen, we have rail 1, 2, 3, and 4, and we can say that the 4 curve inputs that I have will also be 1, 2, 3, and 4. So we'll go around and select them in a clockwise manner. So I'm going to start with 1 curve. Doesn't matter which one you start with, as long as you go in one direction around all 4 of them. So I'm going to start with the first one that we made at the base of the collarbone neck area here. I've selected the curve in Rhino, and then in Grasshopper, if we right click on one of these curve input elements, we can come down in this menu and set the curve to this component. So once you do that, the component will turn from orange to being a light gray color once it's set correctly. And then once we set it, if we come and click on the component in Grasshopper, we'll see it lighting up as green in the Rhino workspace. You have a problem with that? Okay. Yeah.
Am I able to do multiple curves? Yeah, because I did multiple curves to make one. Green. So I should be able to. If I highlight everything I want.
I see it. You'll have to be one.
Oh gosh.
All 3 other endpoints touching.
Yeah. Oh. Okay, well, I will just. That's.
Yeah, you could do that. It's not something you can't do. It just takes a little bit, couple more steps to do it. The way I did it here with the duplicating that single curve is there's some hidden properties of the curve that we can't see that are going to affect how the sweep is going. Every curve has a number of control points, and those control points, when you're doing a sweep, they matter because control point 1 is going to go to control point 1 in the next curve. So if saying, one curve has 5 control points, the next one is 10, the sweep, it might sweep in a weird way. So not saying that you can't have different control points for a sweep. You definitely can if you design it correctly. But this way with the duplicating the curves is just going to be easiest for today. So we're all on this, the same track. But I like the branching out thought. It's nice. Okay, so you've probably already done this, but I'm going to go through and set the rest of the curves around in a circle. Yeah, you could go either way, as long as you're not going from like this inner curve, then to this outer curve, then back to this inner one, and then As long as you're not doing that. And I can visualize, you don't have to do this step, but just to show like what the sweep would do if this was a normal, and it would actually be a loft in this sense. But so I'm going to put them in the order. Actually, we'll use a merge first. Okay, so, and actually let me make this closed. You don't have to do these steps, but just to show, this is what the loft would look like. I just turn off person. This is what my loft looks like with all of the curves selected around in the correct manner. If you were to mismatch, like go from the inner to the outer, back to the inner, I can switch around some of these inputs and we'll see what it'll look like. So if we follow the surface here, we're seeing it's starting on the inside and then jumping to the outside and then coming back in. So we have this large valley created on the inside. What we want to see is a very smooth curve going around the entire shape. So if you want to visualize that, you can do the same thing. You can plug it into a loft to see it, but we will also see it kind of in a similar sense when we plug it into the twisted box sweep. So I'll leave this up here if you want to make sure that your surface is flowing in the correct direction. Okay. Yeah, so the loft just has been closed off. So it's going from 1, 2, 3 to 4, but not back to 1. If that makes any sense.
Yeah.
The loft isn't necessary for this workflow, but as a tip, right click on the O input for loft, the loft, and you can check on close. That'll actually finish. Yeah, so we have the full solve. Yeah, I'll put it up here. So there's 2 ways to do this. Just as a tip for the loft component, we have this other input loft options at the bottom. There's 2 ways to actually set the options. We could grab the component called loft options and set all of the inputs here, which is cool. But something I kind of like more is if you right click on the O input, there's this setting down here that is loft options that pulls out another panel. And then we have this like checkbox section where we can go and flip through all the different settings for this. So all I did was I checked on closed loft. So that'll just take our 4th curve and connect it back to our 1st curve. So it makes a full loop of that surface.
About when you have to flatten things, is that when you have a lot of data?
Yeah. Yeah, it's not going to come up in this workflow. It might come up if we get to the second one, but should I figure out a way? I can kind of describe it quickly. A tough question. There's just so many different like reasons why you would flatten versus graft. But like say you had 2 circles and you wanted to do a different numerical like radius for each one. Now we have like inputs that there are multiple things going in at one input. It's not just one shape anymore. So in that sense, if we had both of these going in to one thing, we could add one radius to it and it'll make both of these circles the same radius. But if we were to like graft both of these, then this first circle would get this first radius and the second circle would get that second radius.
Mhm.
It's a very simplified reason why you would or flatten versus graft, but just saying like there's flows of data and sometimes you want them all to react the same way and sometimes you want to keep them separate so you can add different reactions like to each one.
Okay.
Instead of, you know, if we wanted to make 5 circles with 5 different radiuses, we could have 5 circle components.
Yeah.
But that's kind of static. Like we can't say, oh, now I want 7 circles. You'd have to copy and paste like 2 more things to get 7 circles. Where if you set the data up in the right way, you could just have a slider that says I want 5, and then it does 5.
Okay.
Instead of, you know, doing it 5 times yourself. So we might get to a reason why we would have to do that if we get to the second one today.
Yeah.
We'll see. We kind of did it last class. But it didn't come up too much. It might come up more as we continue on. But yeah, it's something that even people that do it for a couple years still barely understand. Like most people are just, it's not working, so I'll flatten it and then it works.
Yeah,
but there is a theoretical reason for why it's doing what it's doing. There's also another tangent, but there's this whole section in actually this whole sets tab deals with that. So we have like everything that you can do for a single branch. So you can find like a single item out of it. And I think we used list item before where we picked out like the first thing from a list. But there's also all these tree settings where you can affect different branches and things. So there's a lot you can do with it, but not a lot I cover in the first few weeks. Okay, so back to the curves. If your loft is looking good, then we know that these order of the curves is correct. So we'll want to plug the same order into the twisted box sweep. So I'll go ahead and do that. So 1 to 1, 2 to 2.
Oh, wow.
Yeah, so if that works, we should get this like array of boxes morphed into the curves that we set. It won't be as curvy as the loft just because you can't have a curvy box. It only has 6 sides, sorry, 8 points. And by default, we're gonna have 16 of these segments in this line. But the next thing we'll do is update exactly how many segments we want in the twisted box.
How do you isolate it like that?
Like take away the person type thing? Yeah, so I just previewed them off. So if you have the component that has the person in it, you can right click and just preview them on or off. What's better for everyone, to leave the person on or leave it off for the workflow? It shouldn't matter too much. Yeah, leave it on. I figure most people probably have it on, so I'll leave it on. Okay. So yeah. Yeah. So I'll work on this top curve here. If you click on the curve, we should see those control points coming up. So like this point floating out here, which yours probably isn't floating out there. But if you grab any of the points, we can use the gumball to move the curve away, and that'll allow it to be more flowy. And we can even do that right now, and the twisted box will update just because we have those curves always being updated with these components.
I do know, but what the same stairs do in the same.
There's an error? Or
No.
oh, zoom out in the Grasshopper just a little bit. Oh, they're just stuck to that point. Oh, I see. So, like, if you were to grab that, you would handle it.
Oh,
Okay. There's
Oh, yeah.
some setting where you have to turn on, it'll say like lock, but it looks like you're fine. At least that really cool.
Oh,
Yeah, that should be. That must need to work. Okay, so we've got 16 boxes in here. The way we update that is with this lowercase t input. If you hover over it currently, by default, it'll show you all the values it has in there. For a lot of the components in Pufferfish, a lot of them have this lowercase t parameter value, and it always needs a set of numbers with a range from 0 to 1. If you remember from earlier on, we talked about reparameterization a few times with curves and surfaces. What this component's doing is it's basically automatically doing that for all the curves coming in. And then we're saying make a box between 0 and 0.06, 0.06 and 0.13, all the way from 0 to 1 throughout all the curves. So that's how it's making the 16 different boxes. And we can emulate that, do a very similar thing with this range component. The range component, it needs a domain and a number of values to put within that range or in that domain. So I'll click on that. So we can see by default, it already has 0 to 1, which is perfect for our thing. We only want a range of 0 to 1 going into this parameter value. But the one thing we can update is the number. So by default, this one is 10. So if I was to plug the range into the parameters, my boxes just got cut down by 6, and now I only have 10 boxes. But we can use a slider to update this on the fly. So we can have as many as we want. 50 is probably a lot, but so I made a slider from 2 to 50. You can do whatever you want. Maybe not 1,000, but any smaller number. We'll plug that into the N for the range. And as we slide this, we'll see the number of boxes in our twisted box is now growing as I move the slider up. The resolution, say, of the curves is also getting better as we populate more boxes inside the curves. But that's just how it goes with twisted boxes. One thing to note about the range value is I have a number 5 plugged in currently, but coming out, we see we have 6 values. So there's always going to be one more value than the number that you have coming in for some reason. Is that a black screen over there?
No.
Did you actually do the 1,000 slider?
No, I did
Okay.
29. Just adds like.
One more thing I'll note, which this is not necessary, but we have this weighted input at the bottom here. That has a Boolean false true input. If we were to change that, you'd see the twisted box, it updates slightly as it tries to best fit the boxes within the curve system you've made. So it's up to you which one you want to select. I'm just going to leave it nothing plugged in at the moment. It works pretty fine for this workflow at false. Okay, cool. So now we have the twisted box and we have the volume that we want to put inside all of the boxes. If you remember from earlier, we're taking this volume geometry, which is just in a square at the moment, and we're going to morph it to be within these skewed boxes, and it'll take the shape of that. So there's 2 things we have to do to actually take that initial volume and morph it into the geometry of the twisted box. The first thing to do, actually, we'll grab the last component first so we can feel the inputs. There's this component at the bottom here called morph to twisted box. It does basically what it says. It's going to morph some geometry into a twisted box set that we give it. So I'll grab this component. Okay, so we see we have a couple inputs here. First one, geometry. That's the geometry we want to morph into the twisted boxes. The last input, twisted box, that's going to be the twisted box. The second one, though, that's going to be the starting boundary of the geometry that we want to plug in. So in order to put something in a twisted box, it needs to first come from a cube itself. So we take that initial cube, we skew it, the geometry will follow. So in order to get that initial box that we want as the initial, say, twisted box, but not really, it's just a box, is we can use this one component called bounding box. And this is also a very good component to know. I probably use bounding box at least a few times in every single definition that I've wrote. It's just a good way to find the bounding volume of any shape, and it's super quick. It doesn't matter if you have a very complex shape. It'll always give you a very simple six-sided box. So we'll see that populate on the volume at the bottom of our scene. It's just giving it a box that goes around all the extents. It doesn't matter that the box is not like a square cube. As long as we have a box, it'll work. Okay, so now we should have all three of the items that we need to input these into the morph to twisted box. First one being the geometry, so that'll be your mesh plus volume, whatever you chose. The A can go into geometry. Second one, so that's going to be reference boxes to morph from, and it also says typically the bounding box of the geometry. So that works. Plug the bounding box in. Last one, twisted boxes to morph onto. So that'll just be our twisted box system here. And then we'll get all of those shapes coming up and populating the necklace form that we put together. They're working over there.
Isn't there a command that you can set your perspective to the object?
Oh yeah, if it went far away, totally.
I don't know where it went.
So, okay, on the top, or maybe it's somewhere else on your screen, wherever the magnifying glasses are.
Oh,
Yeah, so if you can find the one that says zoom extents, yeah, that works. So since you can't zoom in anymore,
Yeah.
there's another one called zoom target. It's the icon with a little dotted line around it.
Yes.
So if you right click, it'll zoom target, and then you can draw a little tiny box, and the zoom should update.
I think it's just freaking out. That looks weird.
Oh, there's so many selection boxes.
I think it's like not good. Whoa, whoa, that's crazy. And like, look at my X and Y and Z. It's also
pretty awesome.
freaking out.
Yeah,
It looks like Windows.
I try to help students in this class, so good job.
That's
I don't know what.
RJ, what's the command that plugs into a rectangle? I think I missed that one.
Oh, yeah. Probably just restart Rhino, but make sure you save both
Yeah.
since we have geometry in Rhino. Yeah, Henry, it was just a domain with a number. Thinking
Got it,
about it
thank
now, you could probably also not have anything in the rectangle because it'll automatically make a rectangle by default. And it doesn't have to be square, I don't think. But yeah, just putting those in. Okay, so was everyone else able to see the geometry like in the necklace type thing? Like on the screen? Is that working?
I wasn't shooting, but I actually don't have a couple of these things.
Oh, Mesh
installed
Plus?
yet,
Well, okay.
So I'm kind of just following along.
No, I don't know. So you don't have Mesh Plus is what you're saying?
Yeah.
Okay, cool. That's good though, actually. We can do the alternate method. And let me put my grid back on.
What's going on?
Well, that's more of an issue. Well, yeah, Pufferfish is the main one. Nice. We'll use one component out of the Weaverbird. So, let me see. It's not. Why is it not something in? Okay, so just to show, like, you don't need Mesh Plus for any of this to work. You do need Pufferfish though, but we don't need Mesh Plus for this to work technically. We could design our own mesh, and you can do that in a variety of ways. We have all the modeling tools over here, or if you have Rhino 7, we can create weird sub-D objects. Bless you. And we could use one of these as the input. I don't know what it is, but we could use this as the input instead of Mesh Plus, and then tessellate this around our necklace. So to show quickly what that does, instead of using the Mesh Plus part, just like we did with the curves, we could instance the sub-D random thing I made in, and then we could just replace the inputs. So you see it now puts the bounding box around the sub-D, and now we have this weird sub-D being tessellated in my necklace. So you could do that as well. It does look kind of sick, yeah.
Good with that kind of like organic box.
Oh yeah, the sub-D thing is only Rhino 7, and now Rhino 8 that is coming out soon. But
Sub D is or how do you?
yeah, the sub-D. So this thing is the Rhino 7. But I believe you can also do a similar thing with like just the box modeling, if you wanted to. And you don't even have to have one object. Like I could duplicate this and then plug them both in to here. And if I change this from per object to union, now I've got like 2 shapes coming in, but it's a little stretched and weird. So, but yeah, there's a lot of, like, you can pretty much throw anything into a twisted box, suffice to say. So you don't need Mesh Plus, but Mesh Plus is easy for the next step that we're going to do to get to more of a solid shape.
Okay.
Okay, you're back?
I'm back.
Okay, so we wasted enough time. Good. Okay, so in this morphed twisted box, if you hover over the output, you see we have, I have 17 meshes coming out just because I set 17 coming in. That tracks. But all the meshes, they're all disjointed. They're all separate from each other. So what I want to have in the end is going to be one necklace. I want one mesh, basically. The nice thing about the Mesh Plus components, as I said, is they are tileable. So if we put one next to another one, they overlap perfectly. Like all of their vertices line up. Which is really nice because we can just take all 17 of these and we can use a component called Mesh Join. And this will take all of our meshes. And since we have perfect geometry from Mesh Plus, it'll join them all together into one nice mesh. So we can just wire that together. So coming out now, I have one mesh that has taken on all of the faces and all of the vertices from the previous 17. Okay, so now that they're all together, I will demonstrate something. You don't have to follow unless you want to, but I'm going to bake out what I just got from the mesh join. Just to take a look at this model before we move on to the next step where we actually make this look a lot nicer. So if you right click on the mesh join and then hit bake, we can grab the geometry in Rhino and then move it around with the gumball. After bake, there's also another window that usually pops up. You can just hit OK on that second window.
I didn't get that. Could you try again?
Okay, so just to see, it's very low poly because all we've done is taken that original low poly shape and now duplicated it 17 times. But it's something. The next thing we can do is actually smooth it out, and we'll see the geometry a lot nicer and see the pattern coming through. So with the Weaverbird plugin, as I said, it contains a lot of algorithms for smoothing in 3D modeling softwares. The main one and most famous one is going to be the Laplacian smooth. So in Weaverbird, you could also type this in. But we'll be using this first one. So actually, the most famous one is the Catmull-Clark subdivision. Two mathematicians from, I don't know, not 2023 came up with this. And it's just a way to mathematically take faces, add more faces, and then generally smooth all the vertices out. So we'll see what that does pretty clearly here with the next step. So you could grab it from the Weaverbird plugin, or we could type in Weaverbird sub, and we'll use this red smooth quarter of a sphere shape here.
I'm having a problem whenever a bait
Yeah.
is coming.
Okay. So, and you're going from the mesh join, this one. So interesting, but one thing we could do is when we go to bake, instead of just hitting OK, we can hit yes, please group everything, and then hit OK. And then if you select it, it'll select everything and keep it together. Oh, okay. The reason why they might all be separate is because, okay, there might be some components in Mesh Plus that are not tileable. I feel like the one you have is not perfectly tileable, so the vertices aren't lining up. But the Batwing one is, all the vertices will line up correctly. So the mesh join is working, like actually joining.
So I can drag it out, but it's not like the build thing. It's just the lines. No.
Oh,
Maybe it's just because I popped.
are you in shaded mode? If you hit the drop down button on perspective, you can go to shaded, and that should fix it.
Oh, there we go.
Cool. Yeah, we did something real wrong if we just got curves out of that stuff.
Like the programs. Yes, please.
Yeah, it's funny. There's some inconsistencies with Grasshopper. The main one being this very vanilla way to find components with these hand-drawn arrows. I don't know why this is how it is. The graphic design does not make any sense. Yeah, so wait, what I just did, like, so yeah, if you hold Control and Alt and then left click on a component, yeah, it'll tell you where it's found with this very weird graphic design. So yeah, on Mac it's probably Command Alt. Yeah. Okay, might also not work on Mac.
No.
Weird. I was hoping it didn't, and they had like better design when they released the Mac version,
like
but
better
they just didn't put it in at all. Cool.
No.
Yeah, so this is nice. Like if you have like,
Oh wait. It does do it.
oh,
Sharing
it's just
is
pointing
down.
in the wrong spot. Yeah,
It's not pointing to anything.
Huh. The one on the top is pointing to
And the
off into space.
oblivion.
So this is nice. Like, say you download someone else's definition, and then you're playing around with it, and you're like, where'd they get this component from? If you want to find where it's from, it's the way to do it. So sometimes helpful. But yes, okay. So we have the mesh join. So I pulled in this Weaverbird Catmull-Clark subdivision component. If we just run the mesh to mesh, we'll get a new piece of geometry coming out. I'm going to bake this one as well, and we will compare.
Weighted camel bar.
Yeah,
I missed that.
yeah. So if you type, so you have to start typing Weaverbird. You don't have to type the whole thing, but yeah, we just want this red smooth thing. Cool. Nice. Okay, so now we can compare the before and the after of the subdivision. So we can see like on this shape, we can compare straight 1-to-1. We have this face, and now it's been subdivided into 4. I can't select them, they're too small. Into these. No. Okay. So that one shape has now turned into 4 faces. and they all have been like averagely smooth together. So we've gone from something pretty low poly to now a high poly smoothed out shape with this one component. You'll also notice there is no like breaks in the mesh. It's flowing from one of these shapes right to the next one, just because the bat wing volume is very well tileable. So it works out with that weld. If the weld or the join mesh didn't work when you baked it, like it had separate pieces, it might not be flowing as smoothly from one shape to the other. But the Weaverbird should still work, and we'll still get a shape out of it. So it doesn't matter if it's not one single mesh. Okay, so at this point, we have a couple options to make it a fully solid 3D piece that, say, if you wanted to 3D print it, you could. First, probably simplest method is we can take the mesh that we have and just simply offset it, and we'll get a shape. That's one way. Another way, we could use the lines of the mesh themselves, like the curves that make up the mesh, to define a solid. It's another option. But I think easiest thing will probably just be to use this offset mesh for today, so we can get something solid quickly. So we can wire the mesh to the mesh input, and we'll get something coming up in Rhino. With this component, there's a couple options here. First one to check, which by default at the bottom create solid is on true, which is nice because we want a solid shape coming out of this. If it was false, it would just offset the mesh and we would have two separate mesh faces, which isn't what we want. So by default, that should be fine. The one we want to change though is the offset distance. By default, this is at 1, but we could use a slider with whatever number you want to change this offset distance. So we can find a good middle ground that's just solid enough, but not overlapping its neighboring shapes. Once we're at this step, I'm going to bake it again just to show progression. But at this point, we have a solid thing, but if this is 3D printable is the question. So if we zoom in to some parts of the mesh, we can see that we have certain faces overlapping other faces. Like they're just going inside other parts. We might have some vertices that are popping through other sides of the mesh. And places that just have zero thickness, like going through itself. So if you know what like watertight is in a 3D printing sense, this would make sense. But to break it down, we don't want any faces going through other faces. We don't want volumes that are like cut off on the insides of this mesh. So all those issues are going to make 3D printing very tough if you were just to have this as a mesh STL. So one thing we can do to fix all those problems without like zooming in and fixing it manually is in Grasshopper, we will use what we used last week to make the final object in our like wearable shape. And we'll rely on Dendro to clean up all of the issues with the mesh. So back to Dendro, we should have this plugin unless you have a Mac, which in this case, you're done.
Yeah.
You got a cool necklace. But with Dendro, we'll just use a couple components to clean up the final thing. So if you remember from last week, first thing we always need is a settings, and this is going to be how big or small the voxel size is in the whole pattern. So again, we'll use a slider. I usually start with 0.01 to 1. In this scale of the model, this is going to work nicely. And we'll always put the slider up to 1, just because this is going to be the lowest detail setting, but is also going to not just crash our computer out of the gate. we'll start at 1, which there'll probably be nothing will show up at 1, but we can work this number down to find a good resolution for the final mesh. So we can hone that in later. But we'll plug the number into settings just like we did last week.
What is it? Is it one time? No.
Yeah,
Create settings.
create settings from Dendro. So once we have that, we can actually use these settings to create a volume. Last week we were doing a volume from curves, and I think at the end of class we were converting it to points with that script that I gave you. So those are 2 ways to make a volume. The last way is to actually convert a mesh to a volume. So we can use that component mesh to volume. And this will take the mesh that we have with the settings that we just defined and turn it into a volume. So we can wire both of those in. Okay, so at this point, I'm going to hide all of the previous stuff. We don't need it. And yeah, V settings. So we can type in V settings to pull that up. It'll just be called create settings. Or we can find it in this convert dropdown. Okay, so now we have a volume. But with just the volume to mesh, it's not going to show us the volume. Right now, all it's showing us in Rhino is the input mesh itself, which isn't too helpful because we don't know what the volume looks like. But the next component we'll use is going to be the smooth volume. So this will take all of our hard edges and kind of round them off just a little bit. Which this is kind of a visual thing up to you. But if we just have the volume smooth turned on, we'll see what the volume is actually looking like. So we can see with this very high detail setting, we're almost seeing nothing. With 1 as the input. But now we can go take the slider that's at 1 and slowly pull this down, and we'll get detail coming back in as we get to a lower and lower number. We'll just want to go low enough so we see the detail, but not all the way down because it's probably going to be way too much detail. So I'm at 0.08 here, and it looks like it's coming up pretty well. I can see the holes between the pattern and all that. It's not that not that faded anymore. It's coming more into detail. So find a setting that's good for you. But 0.08 is probably also going to work for you since we're in a very similar scale today with this base mesh. Okay, so once we have the volume, now everything looks good. The last thing we just have to do is convert it back to a mesh so we can actually export this thing. So back in the convert tab, the very last button here, we've already looked at everything else, but the very last one is going to be volume to mesh. And this will take it back into a mesh that we can actually work with in Rhino. Again, with the mesh or the volume to mesh, it needs a settings value again. We can create new settings or we can just use the ones from before. It really doesn't make any difference. It's not going to change the voxel size because the mesh doesn't have voxels. So we're good to put any settings component in here. At this point, I'm going to bake it one more time, and we can see the final resolution of this piece. So now if we zoom into this one, we can see the topology of this mesh is a lot cleaner compared to this one where we have all these intersections. It's gotten rid of any of those intersections and just given us one continuous outer surface, which also has one continuous inner volume for this piece of geometry. So with just those 4 components in Dendro, we were able to get rid of all of the overlapping issues that came with our previous mesh. And now if we were to print this on a 3D printer, it wouldn't have any issues with it, other than the fact that there's no flat bottom, but we'll come back to that another day. At least this would give the slicer no trouble to figure out what is the outside and what is the inside of this object. Cool, so at this point we can see it on the character again. I'm just going to turn on that character one last time. Cool, so now we have the final geometry. So that's that workflow. If anyone has questions, feel free. We've got a few minutes left. I'll just look at the other workflow, just showing what that one was doing. So we can go over that. But it is just another way to do twisted boxes. Again, going back to some stuff we talked about at the beginning of this course. So I'll just scroll up here. Let's see. Okay, so some people were bringing up shapes like this one, this facade on this building. If we look at the structure of it, we see it's this one repeating pattern duplicated a lot of times. That could be done with twisted boxes, just with a different workflow, but same method. Same thing for like the shoes from Adidas. That pattern on the bottom is just the same pattern duplicated a lot of times, and they were morphing the twisted box to get the shapes correct on that shoe there. So things like that in the real world made in this method. So you could do that. In this sense, we're just making a fun little necklace, but there are a lot of other workflows that you could do in architecture and design to just use twisted boxes in a different way. Again, we only went through just one of the ways to make a twisted box, but if you really wanted to explore, there's like 50 more that you could look at with different ways to define all of these things. Okay, so looking at the other workflow that I put together today. Let's see.
Yeah. On the building.
Yeah.
That's not a removing pattern.
Yeah, so yeah, I mean you could like morph it by hand if you wanted to, but if I had to assume what they were doing with this one, which I believe it's also just a render. Let me see if I can get a bigger photo. Good enough. Yeah, so they have this one like four-legged pattern. You can kind of see it like right in here, this one cell. And then that's just duplicated to all of the other cells around it. So you could make a spiral piece of surface, add a twisted box with a thickness off of it, and then, you know, with the twisted box, copy and paste that one pattern into all the cells and get a very similar shape to this. So all you would need to design is this one little part, the spiral of the surface, and then with a couple components in Grasshopper, you can get to a facade like that pretty quickly. Yeah. And I did a similar thing with this other workflow, which, let's see, where we took the shapes from last week. Let's see. So last week we were left with these curves. And last week we just thickened them with the volume pipe and then added some colors to it. But one of the other ways you could make a twisted box is just with a single curve. So you could easily take the curves that we made last week, use this twisted box curve variable component, which the only input it needs is a curve. And just like we did with the lowercase t, we could define how many boxes we want on the curves. In this sense, I was setting the number of boxes based on the length of the line itself. So there was no manual setting of the numbers, but if the curve was however long, it would figure out how many boxes it needs to fill that. So that's what all this section is. But basically, you could not have any of that. By default, it would give you boxes on the curve. And then we can see with the curve next to all the boxes, we just basically made a pipe, but with twisted boxes. And then with all of this is from today. We have the Mesh Plus bat wing shape. We're morphing it to the twisted boxes, joining it, smoothing it, offsetting it, and then we get this final shape. So in this sense, now we're wrapping a more complex pattern just around that curve system that we made last week. So just another way that you can define these more complex things. So another little thing. I can post this in the Discord as well, so you can see. It was basically just this section we added between last week's workflow and this week's workflow, just to do another way to make a twisted box. So cool. So that's all I had. If anyone has questions, happy to answer. But if not, I'll see you next week.
Okay.